everyone. I hope you all watched the previous videos. Let's start the session. We are continuing the chapter 4, micro measuring device. Okay. So, right, first question. Which one of the following element of an external screw thread cannot be measured directly with precision instrument? So that is option D, pitch diameter. Okay. Pitch diameter of an external screw thread cannot be measured directly with precision instrument. Okay. The reading of a vernier outside micrometer as shown in the figure is. So here main scale reading. So that is here 11 and 12, right? So 12 mm, 12 mm. Okay. And thimble reading. Okay. Thimble reading. So here that is 24, right? 24 into least count 0.01 mm. So that is equals to 0.24 mm. Okay. And vernier scale reading here it coincides 3. Okay. So 1, 2, 3. It coincides with the third line, right? So vernier scale reading equals to 0.001 is the least count and 3 is the reading here. Okay. So that is 0.003 mm. Okay. So total reading would be total reading that is equals to 12 plus 0.24 plus 0.003. So that is equals to 12.243 mm. Okay. So here the option B. Okay. Depth micrometers are used in measuring different elements of workpiece. For which one of the following measurements a depth micrometer is not suitable? So among the options, the option D is not suitable. So depth of grooves and recesses. Okay. Depth micrometer are used in measuring different elements of workpiece. For measurement of depth grooves and recesses, depth micrometer is not suitable. Okay. The instrument which has all the features of tri-square, bevel protractor, rule, and scriber. So that is combination set. Okay. So this is the combination set. We can observe that tri-square, right? And protractor, bevel protractor, rule, scribe. Okay. Okay. Name the instrument to measure the diameter of a hole. So that is option B, inside micrometer. Okay. So this is the inside micrometer. It is used to measure the diameter of a hole. Okay. So inside micrometer is used to measure the diameter of a hole. Depth micrometer is used to measure the depth of bore slots and grooves. Okay. And outside micrometer is used to measure the outside diameter of a bar or shaft. Okay. And the final one is tube micrometer is right. So tube micrometer is used to measure the wall thickness of tubes. Okay. Name the instrument to measure the height of shoulders and projections. So here the answer is option A, depth micrometer. Okay, this is the depth micrometer. Okay, micrometer can measure up to an accuracy of That is option A, 0.01 mm. Okay, that's the least count. The purpose of ratchet stop micrometer screw gauge is, so it is to maintain sufficient and uniform measuring pressure. Okay, the purpose of a ratchet stop in micrometer screw gauge is to maintain sufficient and uniform measuring pressure. Okay, so you can see here, so this is the ratchet. Okay, what is the zero text of 50 to 75 mm external micrometer? So here that is 50 mm. Okay, so the zero reading of 50 to 70 mm external micrometer is 50 mm. So here the base value is, the starting value is 50. Okay, okay. Circular scale of the micrometer is marked on, that is marked on thimble. Okay, you can see here in the image the circular scale of micrometer is marked on thimble. Okay, you can see this is the thimble. You can find that markings, right? A workpiece has a bore of 12.37 mm, which can be measured by, it can be measured by micrometer. Okay, a workpiece has a bore of 12.37 mm, which can be measured by a micrometer. Okay, micrometer is used for measuring length, diameter, and thickness based on the principle of nut and bolt. Okay, it can measure up to 0.01 mm or 0.001 centimeter. Okay, this is centimeter. So this is called least count. Okay, so we can measure that. So this is how an inside micrometer can be used. Okay, so this is the dial bore gauge. Okay, so we can use inside micrometer and dial bore gauge to measure the diameter of the holes. Okay, so here you can see that you can observe the reading here. Okay, in the dial. Then here we have to calculate here inside the inside micrometer. Okay, the least count of metric micrometer is, so the least count of metric micrometer is 0.01 mm. Okay, metric outside micrometer has a threaded spindle with a pitch of, that is option A, 0.5 mm. Okay, metric outside micrometer has a threaded spindle with a pitch of 0.5 mm. Okay, and its least count is 0.01 mm. Okay, okay. A micrometer has a negative error of 0.03 mm. What is the correct reading when the micrometer measures 40.48 mm? So here correct value equals to micrometer reading plus um, negative error. Okay, plus negative error. Okay, we have discussed this formula many times in the previous session, right? So here correct value equals to micrometer reading is 40.48 mm plus 0.03, right? So the answer would be 40.51 mm. Okay, that is the correct value. Is the answer option B. Okay, option B is the right answer. A metric outside micrometer of range 100 to 125 mm. Okay, 100 to 125 mm is used to measure the diameter of a rod, and barrel graduation showed 16.5 and okay, 16.5, and the thimble graduation line with the barrel datum line was 28. Okay, so what is the diameter of the rod? So here micrometer range is 100 to 125 mm. Okay, so thimble reading here. So here he mentioned that thimble graduation in line with the barrel datum line is 28, right? So 28 into least count, that is 0.01, that is equal to 0.28 mm. Okay, so here reading of the barrel. Okay, barrel reading. Okay, barrel graduation reading. Reading of barrel graduation. Okay, that is equals to, okay, we'll denote this as RB. Okay, so that is equals to 16.5 mm, right? 5 mm. And minimum range is 100. Okay, minimum range of our outside micrometer is 100. Okay, 100, and dia of rod equals to diameter of rod equals to minimum range of outside micrometer, that is 100. Okay, minimum range plus RB, that is reading on the barrel. Okay, RB plus the thimble reading. Okay, plus reading of thimble. Okay, so that is equals to minimum range is 100 plus that is RB 16.5 plus 0.28. Okay, 0.28. So it is around 116.78. Okay, so this is the answer, 116.78. Option D. Okay, option D is the right answer. The least count of an outside micrometer is 0.01 mm. We know that the range of micrometer is 75. Okay, 75 to 100 mm. The barrel reading is 15.50. Okay, barrel reading, and the 10th thimble graduation coincides with the barrel datum line. The reading is here least count. um, so thimble graduation. Okay, reading on thimble, that is equals to higher coincides with 10th graduation, that is equal 10 equals to, sorry, 10 into 0.01, that is the least count. Okay, so here the answer is 0.1 mm. Okay, and reading of micrometer, reading on barrel given, right? Okay, reading of micrometer, reading of micrometer, that is equals to um, reading of barrel plus thimble reading. Okay, reading of barrel plus reading of thimble. Okay, so that is equals to 15.50 plus 0.1. Okay, let it be 0.10. So total is 15.60 mm. Okay. And here he asking about the yeah reading only. So here 15.60 is answer. Okay. The accuracy of a vernier micrometer is that is plus or minus 0.001 mm. Okay. Vernier micrometer. I have given you the least count of each and every instrument. Okay. So just go through it once. Okay. Ratchet stop in micrometer it helps to control the pressure. We discussed that, right? So it closes the spindle by turning the ratchet, not the thimble. Okay. The ratchet prevents excess pressure on the object being measured. Okay. So you don't squash it and get a false reading. Okay. Zero error in micrometer means. So the zero error on in micrometer means zero on thimble and datum line on sleeve do not coincide when measuring faces are in contact. Okay, you can see here in the image there are the two zero errors. Okay, the first one has no zero error because it coincides with the zero line. Okay, but here if you see positive zero error, so zero on the thimble is not coincide with the datum line. Okay, so it is below the datum line. Okay, this is the datum line. So thimble reading 0 is below the datum line. Okay, so that is positive 0 error. So if 0 is above the datum line, okay, on thimble reading, so that is negative 0 error. Okay, in metric micrometer a complete revolution of thimble advances. So it advances 0.5 mm. Okay. So in metric micrometer, a complete revolution of thimble advances 0.5 mm. Okay. An outside micrometer has a negative error. The correct reading can be taken by. It can be taken by adding the negative error in the actual reading. Okay. So we discussed that correct reading formula, right? So that is correct reading equals to here he mentioned negative error. Okay, so I'm writing that first. So micrometer reading plus, okay, here negative, if it is negative error then add it. Okay, plus negative error. Okay, sorry, you may get confused, right? Plus negative error. Okay, and or micrometer reading minus positive error. Okay, if it is given positive error, then subtract from the micrometer reading. Okay, positive error. Okay, okay. So which one of the following is not a part of micrometer? So that is leg. Okay, leg is a not a part of micrometer. Okay, you can see here different parts in micrometer. Okay, ratchet stop is there, thimble is there, sleeve with vernier graduations are there, spindle, anvil, lock nut. Okay, frame. Okay, different parts of the micrometer. Okay, pitch diameter of an external thread is measured using a. It is measured using a screw thread micrometer. You can see here in the image, this is the screw thread micrometer. Okay, so it is used to measure the effective diameter of screw threads. Okay, this dimension is important because the area of the thread flanks in the vicinity of the pitch line is where the greatest transmission of force occurs between mating threads. Okay, pedometer micrometer is used for it is used for measuring of external diameter. You can see here in the image. This is the digital pedometer micrometer. Okay, so the shaft will be placed between like this. Okay, so we can measure the external diameter. Okay, the reading will be shown here. Okay, which instrument is used to measure the internal dimension of part, such as internal diameter of a hole? See here, they're mentioning internal, right? So endo means internal, right? Endometer micrometer is the right answer here. Okay, hole or a tube. Okay, so option A is the right answer. What can an endometer micrometer be used to measure? So it is used to measure what? Internal diameter of a pipe. Okay, so endo here means internal, right? Inside. Lock nut in the micrometer is provided to. It is provided to log the reading after setting it over the workpiece. Okay. The standard tool used to measure the diameter of an internal recess. So that is 3-point internal micrometer. Okay. So here in the image you can see that is the 3-point internal micrometer. Okay. So you can observe there are three heads here. Okay. And one main body, scale on thimble, patched stop, same. Okay. So it is used to measure the internal diameter. Okay. Metric outside micrometer has a threaded spindle with a pitch of. We know that that is 0.5 mm. Option A. Okay. An inside micrometer cannot be, okay, cannot be used for measuring. It cannot be used for measuring external features. Okay. Inside micrometer is used for internal features, not for external features. Okay. Option B. Okay. So an inside micrometer is used to measure the large internal dimension. Okay. And it can measure internal diameter of holes. Okay. A micrometer has negative error. Okay. Negative. Okay. What is the correct reading when the micrometer measures 40.53 mm? Okay. So here true reading or a correct reading equals to uh, micrometer reading. Negative means here plus, okay, plus and negative error, okay. So that is equals to 40.53 plus 0.03. So answer would be how much? 40.56, right? 40.56 mm. Okay, so option B. Okay, 40.56 mm. Okay, option B is the right answer. Micrometer can measure up to, it can measure up to least count. Okay, so you may get confused, but here it is simple one, right? The tool which is used for outside diameter is, so that is outside micrometer. Okay, A depth micrometer can be used to measure. It can be used to measure length of the bore. Okay, you can see here in the image. So this is the blind hole. So this is the depth of the slot. Okay, so this is the depth measured by the depth micrometer. Okay, so the length of the bore is the right answer, option B. Okay, accuracy limit of stick micrometer is, so that is 0.005 mm. Okay, you can see here in the image, this is the stick micrometer. Okay, stick micrometers are designed for measurement of longer internal lengths. Okay, so a 150 mm or 300 mm micrometer unit fitted with a micrometer of 25 mm range and having rounded terminal faces. Okay, a series of extension rod which together with micrometer unit permit a continuous range of measurement up to the maximum length required. Okay, the pitch of threads of a screw gauge is 0.5 mm. The number of divisions on the thimble is 25. The least count of the screw gauge is. So here least count equals to pitch of thread. Okay, pitch of thread by number of divisions on thimble. Okay, number of divisions on thimble. Okay, so that is equals to here pitch is 0.5, right, by how many? Yeah, 25. So here 0.02 mm is the right answer. That is option B. Okay. In micrometer, if zero graduation of the thimble is above the datum line, when the faces are in contact, the error is negative error. Okay. So we discussed that. You can see here in the image. So the zero on the thimble is, all right. Okay. So the zero on the thimble is above the datum, right? Datum line. So that is the negative. If it is bottom, then it is a positive. If it coincides, then no, zero error. Okay. The zero error of a micrometer is plus. Plus means positive error. Okay. Plus 0.001 mm. Okay. What will be the reading of micrometer to measure 0.715 mm? Okay. So we know that formula, correct reading equals to micrometer reading plus, sorry, here it is positive error, right? So we'll subtract from micrometer reading. Okay, so minus positive reading. Okay, so here he asks micrometer reading, so correct reading plus positive reading. Okay, so here correct reading is 0.715 plus 0.001 mm. So here the answer is 0.716 mm. Okay, so option A. Okay, yeah. The value of one thimble division of a metric vernier micrometer is, so that is 0.01 mm. Okay, parallel division of sleeve of British vernier micrometer is, so that is option C9 by 1000. Okay, so you can see here, this is the British vernier micrometer. Okay, you can see this is the sleeve scale. Okay, you can say main scale and the thimble scale. We know that, but If you observe, this is the vernier scale. Okay, the parallel lines parallel to the datum. Okay, so the parallel lines are considered to be vernier scale. Okay, so this is how the uh, dimension can be measured. Okay, you can see that 2 here, so that is point 0.2. Okay, 0.2, and 3 inside divisions are there. So before 3, so each one is considered 3 into 0.025, right? Point, um, 0.075 is answer, okay? And it coincides with, okay, nearby 11, okay? So the reading is 0.011, okay? And the parallel lines coincide with the second line. So here start with the 0, 1, and 2. So it coincides with the second line. So with the least count, we can get that 0.0002. So by summing up, we will get 0.2862. Okay. The value of one thimble division of British vernier micrometer is. So here the answer is 1 by 1000. Okay. Diameter of finished turned shaft can be checked with micrometer. Okay. Figure shows a depth micrometer, and we have to name the parts in alphabetical order. Okay. So option A is ratchet. We all know that, right? Option A is ratchet, and option B is thimble. Okay. I'll write it. Ratchet, thimble. Option C is base. So this is the base. Okay. Option D. Option D is here it is lock nut. Okay. Option Option E is depth rod. Okay. Extension rod. Depth rod. Okay. And option remaining is F. F is a sleeve. Okay. So ratchet, thimble, base, lock nut, depth rod, sleeve. Option A is, sorry, option 1 is right answer. Okay. Millimeter scale in micrometer is marked on, that is marked on barrel. Okay. The axial advancement of thimble is known as which in a micrometer when thimble completes one revolution. Okay. So option A. In a vernier height gauge, when the jaws touches the work table, vernier scale shows. It shows a 0 reading. Okay. For measuring in British and metric unit, so dash, that is option D. Okay, same vernier but different micrometer can be used. Okay, so for measuring British and metric units, vernier is same. Okay, but micrometer is different. Okay, what is the least count of depth micrometer? That we know that 0.01 mm. Okay, what is the depth micrometer used for? It is used for measure of depth hole. Okay, depth of a hole. Which instrument can be used to measure the thickness of sheet of paper? So that is micrometer. Okay. Inside micrometer is used to measure accuracy of which level? That is 0.01 mm. Okay, that is the least count. By which micrometer will you measure the thickness of pipes and sheet? So that is outside micrometer. Okay, here he mentioned thickness. So outside measurement can be measured by outside micrometer. Okay, the part of the micrometer that equalizes the pressure measured is, that is ratchet. We all know that. Okay, depth micrometers are used to measure. So all of the above. Okay, it can measure depth of holes, depth of grooves and recess, heights of shoulders, and projections. Okay, extension rods are extra features for inside micrometer. Okay, so this is the extension rod. Okay, so this is how if we need extra rods for extra dimension, so rods can be attached. Okay, in micrometer, random errors are also called as accidental errors. It is not because of which cause. So it is level of measuring surface. Okay, it is not because of level of measuring surface. Okay, I'm showing accidental errors or compensating errors here. So the first one is random in nature. Okay, and don't have many fixed pattern. Okay, can be positive or negative, follow the law of probability. They have small magnitudes and tend to distribute equally on both sides of true value. Okay. Many times dust, soil, etc. gets deposited on measuring faces of a measuring instrument. If we measure without cleaning it, then error on measurement occurs. This error is called, that is contact error. Okay. The British micrometer has least count of, that is 0.001 inch. Okay, so these are the British and metric micrometer least counts. Okay, okay. The accuracy of a metric vernier micrometer is dash times. Okay, is dash times that of an ordinary micrometer. So that is 10 times. Okay, option C. The least count of the indicator micrometer is, so that is 0.001 mm. Okay. Screw thread micrometer is used to check dash of the screw. So that is pitch diameter of the screw. Okay. In a screw thread micrometer, the dash part is replaceable. So that is anvil. Okay. Anvil can be replaceable. The screw thread is checked by micrometer width. That is V thread. Okay. The screw thread micrometer is used to check pitch diameter. Okay, and its least count is 0.01 mm. The thread is 1 inch on the spindle of the British micrometer hour. So that is 40. Okay, so the pitch of micrometer thimble screw is 40 TPM is thread per inch. Okay, each turn of the thimble moves the spindle exactly 0.25 inch. Okay, the barrel of the thimble is divided into 25 equal parts, each of which is 1 by 1000 or a 0.001 inch. Okay. The thread are cut in the spindle of the micrometer. So that is single start. Option D. the thread are cut in the spindle of micrometer is single start. Okay, the spindle is a very accurately machined screw, and the object to be measured is placed between the spindle and anvil. Okay, the spindle is moved by turning the ratchet knob or thimble until the object to be measured is slightly touched by both the spindle and anvil, which is called as safe micrometer. So, which consists ratchet stop and that is working. This is called as safe micrometer. So, option C. Okay. The faces of micrometer, spindle and anvil are made of. So, both are made of carbide. Okay. The face of micrometer, spindle and anvil are made of carbide. Okay. And the spindle is one end of the spindle is the measuring face. The other end is threaded and passes through a nut. Okay. The threaded mechanism allows for the forward and backward movement of the spindle. Okay. And anvil. Anvil is one of the measuring faces which is fitted on the micrometer frame. Okay. The least count of metric micrometer is. So the least count equals to distance covered by spindle in one revolution. Okay, distance covered by spindle in one revolution by the number of total parts on the thimble. Okay, the number of total parts on the thimble. Okay, so least count is sorry here distance covered by spindle in one revolution, that is off. Okay, by the total number of total parts on the thimble. So that is 50, right? So least count equals to 1 by 100 mm. Okay, or that is equals to 0.01 mm. Okay, so here option B. Okay, option B is the right answer. When a micrometer has positive error, when a micrometer has positive error, thimble's zero is at the back of sleeves datum line. Okay, so option C. Okay, so you can see here in the image. So this is the sleeves datum line. Okay, datum line. Okay, so here this is the thimble's zero. Okay, this is the thimble. Okay, so it is below the datum line. Okay, so that is positive zero error. Okay, when a micrometer has negative error, so the thimble zero is at front of datum line of sleeve or barrel. Okay, you can see here in the image. Okay, so it is, this is the datum line, right? Datum line. So this is the thimble zero. So it is above the datum line. So that is the negative error. Okay. The measurement taken with V annual micrometer is, so that is option D, 3D by 2. Okay. The measurement taken with V annual micrometer is 3D by 2. Tube micrometer checks. It checks thickness of pipe. Okay. Cube micrometers have a cylindrical anvil positioned perpendicularly to a spindle and is used to measure the thickness of tubes. Okay. Micrometer stops are micrometer heads that are mounted on the table of a manual milling machine, bedways of lathe, or other machine tool in place of simple stops. Okay. A characteristic of automobile micrometer is that is it anvil is replaceable in which measurement can be taken in range of 100 mm from same micrometer. Okay. The spur gear is checked by a flange micrometer. The spur gear is checked by a flange micrometer. Caudal thickness. Okay. Option A. The brown and sharp flange outside micrometer has disc-shaped faces with flanges for measuring the pitch of gear teeth and a vernier scale in inch units for taking precise outside diameter measurement. 3-point internal micrometer is used to measure diameter holes up to dash mm. It is up to 10 to 20 mm. Okay. Digital micrometer is a modern micrometer. Its main feature is its zero reading can be set anywhere. Okay. So option C. Its least count is 0.001 mm. Okay. Depth micrometer does not consist frame and anvil as outside micrometer. Also, it is different from outside micrometer in which way? So, it's option D. From this reading of departments covered by symbols are taken. Okay. What is the function of ratchet stop of micrometer? We have discussed a lot, right? So it gives proper pressure for reading. Okay. By which instrument the internal measurement of bore hole can be measured with utmost precision. So that is inside micrometer. Okay. Inside micrometer is a device designed to precisely measure things such as the inner diameter of holes, where a standard micrometer might be used to measure the cutter diameter of a bolt, and inside micrometer could be used to measure the inner diameter of a nut. Okay. Which instrument is used to measure depth pitch? So, screw thread micrometer instrument is used to measure depth pitch. So, option C. Okay. Accuracy of micrometer is determined by the number of marks on the screw cap and its finger. Okay. What is the minimum measurement that a micrometer can take? So he is asking about the least count. So that is 0.01 mm. Okay. The rotating part of the micrometer on which 25 or 50 marks are made is called. So that is called thimble. Okay. The rotating part of the micrometer on which 25 or 50 marks are made is called thimble. Okay. This thimble is component that encompasses the barrel. In order to calculate the rotations, it contains circular measurements. Okay. The least count of a micrometer is. So we know that is 0.01 mm. Okay. So we're going to the vernier chapter. Okay. That is second chapter. In that first question, the diameter of a tennis ball can be measured directly using a So that can be measured directly using a vernier caliper. Okay, vernier caliper can be used to calculate the diameter of a tennis ball. Okay, okay. What is the formula to find the least count of vernier bevel protractor? So that is option C. Okay, 2 times the main scale division minus 1 VSD. That is vernier scale division. Okay. So vernier bevel protractor is a precision instrument meant for measuring angles to an accuracy of 5 minutes. Okay, 5 minutes. Okay, or 1 by 12th degree. Okay, or 1 by 12th degree. Okay, that is 12th part of 1 degree. Okay, which of the following is a precision measuring instrument? That is vernier caliper. Okay, vernier caliper is a precision measuring instrument because it measures the precise value of linear dimensions. Okay, its least count is 0.02. Okay, least count is 0.02 mm. Okay, the part of the digital vernier caliper which differs it from others is known as, that is, LCD display. You can see here in the image. So this is the LCD display where you can observe the dimension. Okay. In vernier caliper, which one is smaller, main scale division or vernier scale division? So here the option is vernier scale division. You can see here in the image, this is the vernier caliper. Okay, I hope you all know that. So here in vernier caliper, vernier scale division is smaller than main scale division. Okay, vernier scale division means vernier scale division which is 9 long and consists of 10 divisions. Okay, each division on the vernier scale is 0.9 long or 0.1 less than the main scale division. Okay, so you can observe here, this is the vernier scale. Okay, you can observe the dimensions here. Okay, this is the vernier scale. Okay, this is the main scale. Okay, the vernier bevel protractor one division value is, so that is how much? 1 degree. Okay, vernier bevel protractor is used for measuring angles. We know that. It can be measured up to an accuracy of 5 minutes. Okay, value of 1 division in vernier bevel protractor is 1 degree. Okay, the vernier scale of caliper has 50 divisions, which coincides with 49 main scale divisions. If each main scale division is 0.5 mm, then the least count of the vernier is. So here he is asking about least count, that is equals to main scale division minus vernier scale. Okay, MST minus VST. Okay, so here he given that 50 vernier scale divisions. See here, 50 division vernier scale here. Okay, 50 vernier scale divisions equals to 49 main scale divisions. Okay, so 50 VST equals to 49 MST. Okay, so here 1 VST equals to uh, 1 VST equals to how much? 49 by 50 MST, right? So here, so we will simplify this 49 by 50. Let it make 1500. Okay. So how much? that is 0.98, right? 0.098 MSD. Okay. So 1 VSD equals to 0.49 mm. How? So, so here 0.098 into zero point 0.5 mm. So here each division is 0.5 mm, right? So 0.5 mm is there. So 1 VSD equals to how much? 0.49 mm. Okay, 1 VSD. Okay. So the formula least count equals to main scale division is 0.5 mm. Okay, 0.5 minus here 1 MSD. Okay, 1 MSD minus 1 VSD, right? So here 1 main scale division is 0.5 mm and 1 minor scale division is 0.49 mm. So the least count is 0.01 mm. Okay, so option C, right? Okay. Name the part to which the depth bar of vernier caliper is attached. So that is movable jaw. You can see here in the image. So this is the depth bar. Okay. So this is the depth bar. It is attached to the movable. Okay. Movable jaw. Okay. In a typical vernier caliper, 50 divisions of the vernier scale occupy 49 divisions on the main scale. While measuring the diameter of a rod, the main scale reading shows 24 mm, and the 20th vernier scale division coincides with the main scale. What is the diameter of the rod? Okay, here main scale division equals to 1 mm. Okay, so 50 vernier scale division equals to 49 main scale division. Okay, so 1 VSD equals to 49 by 50 MSD. Okay, main scale division. So that is 0.98 mm. Okay, so the least count equals to here main scale division is 1 mm minus 0.98 mm. So the least count is to be 0.02 mm. Okay, so here they asking about the diameter, not about the least count. So diameter equals to main scale reading plus vernier coincidence, okay, into least count. Okay, so that is equals to 24 plus 20 into how much? Okay, 0.02. Okay, least count is 0.02, right? So 28th the vernier is coincides, right? So the answer would be 24.4, right? So A, option A is the right answer. If the 9 main scale divisions are divided into 10 equal parts in the vernier scale, what is the least count of the vernier caliper? So here 9 main scale divisions equals to 9 mm. Okay, so 1 MSD equals to 1 mm, right? Okay, so 10 vernier scale divisions equals to 10 vernier scale divisions equals to 9 mm. Okay, 1 VSD equals to how much? 0.9 mm. Okay, so we know that least count equals to 1 main scale division means 1 vernier scale division, right? So 1 mm minus 0.9 mm. So the least count would be 0.1 mm. Okay, that is option D. Okay, internal diameter is measured by the internal diameter is measured by vernier caliper. Okay, least count of vernier height instrument in metric system. Okay, so that is option C, 0.02. Okay, vernier height gauge is used for measurement of which of the following. So that is external dimensions. Vernier height gauge are used in metrology and metalworking to detect or measure vertical distances. Okay, vertical height gauge is used to measure height or external dimension. Okay, the least count of a vernier caliper in which 19 main scale divisions are divided into 20 equal divisions in the vernier scale will be. So here he asking about the least count. So least count is one main scale division minus one vernier scale division. So here 1 VSD equals to 1 VSD equals to, I'm directly writing it down, okay, 19 by 20, okay, MSD, okay, 20 vernier scale divisions and 19 main scale divisions, right? So least count equals to 1 MSD minus 1 VSD equals to how much? 1 MSD minus 19 by 20 MSD, okay? So that would be how much? 1 by 20, right? That is equals to 0.05 mm. Okay, option D. Okay, determine the least count when one main scale equals to 1 mm and one vernier scale is equals to 9 by 10. So same procedure here, 1 VSD equals to 9 by 10 MSD. Okay, and the least count equals to 1 MSD minus 1 VSD, that's equals to 1 MSD minus 9 by 10 MSD. Okay, so that is equals to 1 by 10 MSD. So that is equals to 0.1. Okay, 0.10. Sorry, 0.1 mm. Okay, so here option B. Okay, vernier caliper part used to measure depths of an object or holes. So that is depth probe. Okay, the vernier caliper part which is used to measure depth of a object or hole is depth probe that is attached to the movable head and slides along the center of the body. Okay, the least count of vernier caliper we know that 0.02 mm. Okay, name the part marked X in the given figure. So it is movable chuck. Okay, which one of the following instrument directly gives the actual dimension? So that is vernier caliper. Okay, which part of the given vernier caliper, as shown in the figure, is used for measuring internal radius? So these two are used for measuring internal radius. Okay, so these two are called inside jaws. Okay, and option B, these two are outside jaws. So object will be placed like this. So object here will be placed like this. Okay, will measure the inside diameter. Okay, like rings. Okay, option A is the right answer. The difference between one MSD and one VSD is vernier caliper is. So here he asking about the least count of the vernier caliper. So that is 0.02 mm. Okay. The least count of vernier bevel protractor is. So we know that that is 5 minutes. Okay. In a vernier micrometer, vernier scale is graduated on. Vernier scale is graduated on barrel. Okay. You can see here in the image. So in a vernier micrometer, vernier scale is graduated on barrel and circular scale is graduated on the thimble. Okay. So that is the difference. Okay. What is the specification of vernier height gauge? So that is height of the main scale, option D. Okay, few more are there. Clear specification of the range of the measurement. Okay, and any specific requirement reading the type of vernier desired. Okay, type of scale desired, height of the beam. Also the specifications of a vernier height gauge. Okay. The least count of vernier bevel protractor is. We discussed that previously. That is 5 minutes. Okay. To get least count of 5 minutes in vernier bevel protractor, the 23-degree main scale are divided into. That is divided into 12 equal parts on vernier scale. So option A. Okay. The least count of vernier depth gauge is. So that is 0.02 mm. Okay. While laying out, the vernier height gauge must be used on the, so that is used on the surface plate. Okay. While marking with a vernier height gauge, the workpiece is generally, so that is supported by an angle plate. Okay. Angle plate is used with the surface plate for supporting the workpiece in perpendicular direction. Okay. The reading of a vernier caliper as shown in the figures. Here all options are 25, so main scale division is 25 mm. Okay, and here if you observe around yeah 20, it coincides, right? So 20 divisions of vernier scale coincides with the main scale. So here reading of the vernier caliper reading equals to main scale. I will put it main scale division plus vernier scale division into least count. Okay, so here main scale division is 25 plus vernier scale is 20 coincides, right? So and 0.02 is the least count. So 25.40 is the right answer. 25.40 mm. Okay, option C, right? Yeah, the least count of a vernier outside micrometer is. So we know that that is 0.01 mm. Okay. Outside micrometer are used for measuring the thickness or outside diameter of a small parts. While measuring with vernier bevel protractor, which part is used normally as reference surface? So that is option A, stock. Okay. On which part of the vernier bevel protractor are the main scale divisions graduated? So that is disk. Okay, you can see here in the image. So this is the main scale and this is the disk. Okay, so you can observe the stock. Okay, here. So stock is used to normally as a reference surface. Okay, and locking screws, vernier scale, and that. Okay, these are the parts, and adjustable blade is there. Okay, the ends are 45 degree and 60 degrees. The least count of the vernier caliper is equal to, that is 1 MSD minus 1 VSD, right? Option A. Which one of the following instrument is used to measure accurately the angle of taper? So that is vernier bevel protractor. Okay. The minimum measurement that can be correctly read with a vernier caliper is. So that is least count. Okay. That's all for today. Okay. Thank you.